So here are some common continuous distribution. So uniform, exponential, normal, chi-square, student T and F. But let's start with uniform. The uniform is very similar to the discrete version, but you just take continuous value, right? A lot of value instead of discrete. So you're saying this in those ranges, everything is equally likely. For example, the support is between A and B, some finite number, and an example, the density function usually is say between B and A. The density function is defined 1 over B minus A, because why you define it this way? Because you integrate it between B minus A, right, will be 1, right? Because this is a rectangle, right? The area under the curve, right, is when you integrate, it's a rectangle, is a area under the curve, right? The curve has height B minus A, and this is the height, all right, and the length is B minus A, right, because it's between A and B. So the rectangle will give you 1. So that is the idea why you have this, okay? And the distribution function is integration of this density function, right? And this can be taken out, integrate, become x, right? It's x minus a. So this is how this is being here. And we'll prove, and so y mean and variant is like a plus b over 2 and b minus a over 2, b minus a squared over 12. The 12 is a little bit tricky, but you understand why we have over 12. So here is the graph for uniform distribution. If a is 2, b is 1, right? It's 1 times 1 is 1, right? Because the area under curve is the probability, right? So this 1/4, right? A quarter times 4 is 1. Okay, so let's see these the expectation. Okay, expectation x is x times the density function, right? And integrate the range between a and b, right? B over a can be taken out. X become x squared over 2, and it's taken b minus a, so it's b squared minus a squared. It's then you cancel out, it become a plus b over 2. Okay, so to calculate the variance, again we do the second moment. Okay, ex squared and equal to x squared of this guy, right? And you take this out. Integration is x3 over 3, and you take b3 minus a cubed will be b squared plus a squared plus ab, right? So that is why we have this. So now the variance, okay? So the variance is this formula, but we will be not using this exactly. We are using this idea, expect x squared minus ex, okay? So ex squared, so this is the what we're actually using. And you just took the common denominator 12, okay? Because it's square, it's 12. So that's how you get the 12, and you simplify, right? Because multiply by 4, you have up 4 here, and then this is a squared b squared plus 3. So let's view with b minus a. Okay, this is n for the uniform.